record. Okay, so you're being recorded, FYI. Okay, so we've talked about acids and bases at this point. Hopefully y'all got some practice yesterday. So I'm working on adding like comments to your worksheet, so you'll be able to see corrections. You still get credit, you know, for whatever you did, but I think it would be helpful to see like, oh, hydrosulfuric acid, that should be H2S, not H2SO4, things like that. So I'm hoping that if I do these comments, you will be able to see them, but this is new to me. So we'll see. Okay. So does everybody have the notes at this point? We good to go? All right. Ooh. So pH and pOH. All right. So when we are looking at these things, I want to keep in mind our definitions of acids and bases. Now, pH and pOH should be things that you are familiar with, you know, from your science courses in the past. Okay. So as a reminder, we said an acid is a proton donor. Okay. Remember that a proton is the same thing as a hydrogen ion. Okay. So when someone is talking about a proton, you know, giving off a proton, that's the same thing as saying a hydrogen ion. Okay, so no worries there. And then for our bases, right, they had a two-part definition. Okay, they are going to accept protons or accept hydrogen ions, and they also can give off hydroxides in water. Right, there's two parts to that base definition. Okay. And again, we had the like, anything that contains hydroxide is a base, but not every base contains hydroxide. And that's why that definition has the two parts there, okay? And so we have these definitions. We have what it means to be acidic, okay? It gives off hydrogen. But there are different ways that we can talk about how strong something is. You know, if you eat a clementine, your tongue is fine. You're not in a lot of pain after you eat a clementine. Whereas if you eat a few warheads, your tongue is going to start to hurt, okay? Because there are different strengths of acid. Something can be more acidic or less acidic than something else. And so we are going to use one tool that we have to measure, you know, acidity is something called pH. Okay, so if you have a pool, maybe you've seen people like using those little water sample vials in your backyard, or if you've used those little pH strips, that's what they're called, those indicator strips. You may have seen those before as well. Okay, so what those are looking at, okay, oh, sorry, you don't want that. And so, like I said, it's measuring how much hydrogen is going to be in that solution, and it's telling us its acidity. So we have an equation, and so I want everybody to get your calculators. So if it's not nearby, go ahead and grab it, please. When we are talking about logs, right? So sometimes people look at this equation and then they start having very bad, scary vibes. No scary vibes allowed, okay? I do not need you to be pH experts to do this, okay? Or log experts, rather. What I need you to be able to do is just find the log button on your calculator, okay? So looking at your calculator, it should be on the left. Virtual background causing issues. Let's turn that off. You'll see my closet, which isn't too bad. I turn my background off so you can see my calculator. There we go. Okay. So when we are looking at our calculator, here is that log button. Okay. The other thing I want you to make sure you are being careful about is that negative key in front. Okay, so that's a negative key, not a subtraction. All right, so your negative key is down at the bottom, okay, by the decimal. That's your negative key. And so when you're plugging these things into your calculator, you want to press negative log, okay? And then whatever the number may be, okay? Often you are going to see very small numbers, okay, using exponents. So I want to remind you guys about using your E feature, right? So if you were told that the hydrogen concentration was 1.2 times 10 to the negative fifth, let's say. Just a quick refresh about using that on your calculator. You're going to type negative log 1.2 and then E negative 5. Remember, to get that E, you're doing second comma. Okay, so if you need a refresher, make sure you write that down. Okay, so that is what you are going to enter into your calculator when you're plugging these things in. Okay. And so anytime you do this, again, make sure, right, last thing to remind you, negative key, not subtraction. Otherwise, you're going to get an error or the incorrect answer. So we don't want that. Calculator errors are the worst. Okay. Any questions about putting these things into our calculator? Okay, cool.
Where do you find log again on the calculator?
Yeah, it's on the left-hand side. It's next to the 7. Cool. All right. So let's see. So on the next slide, you've got an example there. It says pH equals the negative log of 1 times 10 to the negative 7th. Okay. That next piece is in there if you're familiar with logs. If you are not familiar with logs, I don't care. You can totally ignore it. If it freaks you out, scratch it off. Okay. It's just everybody's at different places with logs. And so I put it in there for friends who think logs are great and easy. These are all base 10. If you do not think they're great and easy, then just don't read that. Okay. So it says extra practice. So let's, I'm going to give you some to do, and then I just want you to calculate their pH. And when you get your answer, go ahead and plug it into the chat feature. Okay, so again, when you are done plugging those in, just put like 1 and then your answer, 2 and then your answer. One question that does come up often is about units. There is no unit for pH. The answer is like 5.
Wait, is that a 2.3 or 23?
2.3.
Oh.
Which would explain why you're off by 10. I figured. Okay, so most of us look like we're getting pretty close. Okay, so the first one, because it was 2.3, we're going to keep 2 sig figs, and so that answer should be 5.6. The second one, friends, 0.0234. How many sig figs is that? Three. Okay, so our answer should have 3, which would make it 1.63. Okay, so just paying attention to those little sig figs. All right. So then over here, what these numbers even mean, what's the point of them? Okay, so we have acidic, basic, and neutral. These are words that we use, and the pH scale helps us to put things into that category. So if something is acidic, that means that the hydrogen concentration is greater than the hydroxide concentration. Okay, if something is acidic, its hydrogen concentration is greater than the hydroxide concentration, and the pH will be less than 7. Okay. pH will be less than 7. The lower the pH, the more acidic it will be. So like a pH of 1 is more acidic than a pH of 5. Okay, the lower the pH, the more acidic that solution will be. If something is basic, okay, that means that there is less hydrogen than hydroxide. There is less hydrogen than hydroxide. Who's bothering you, Linton? And the pH is going to be greater than 7. And the closer to 14, the more basic something will be. Closer to 14, the more basic something will be. Yeah, Michaela. Yeah, I said you, Michaela.
Can you repeat the last thing you said about it being acidic? It cut out for me. After
the lower the number, the more
Yeah.
acidic something is.
Okay, thank you.
That's what I said. Like the closer to 1, something along those lines. And then if something is neutral, your hydrogen and hydroxide concentrations are the same, and the pH equals 7. If something is neutral, the hydrogen and the hydroxide concentrations are the same, and the pH is 7.
What was the first thing you said for basic?
Hydroxide, the hydrogen concentration is less than hydroxide.
Thank you.
Huh? All right. So just like the pH scale, we have something that we call the pOH scale. And it is the ideas behind it are very similar. It's just the complete opposite of the pH scale. So your pOH scale is called the power of hydroxide. It's measuring how much hydroxide is in your solution. Okay, so your pOH stands for power of hydroxide and is measuring how much hydroxide is in your solution. The pOH scale itself is the opposite of the pH scale, meaning if you are less than 7, it is basic. Okay, so a pOH less than 7 is basic. A pOH greater than 7 is acidic. And a pOH equal to 7 is still neutral.
Can you say what a pOH is again?
Yeah, it's the power of hydroxide. And it's measuring the hydroxide concentration in a solution. So the equation for this thing is the same. Okay. In that you are still doing the negative log, but this time instead of taking the negative log of hydrogen, you are taking the negative log of hydroxide. So the process is still the same. You would press negative and then the log button on your calculator, but here you're plugging in hydroxide concentration instead. So over there it says practice. If the hydroxide concentration is 0.0023 molar, what would the pOH be? And so what you would plug in is negative log 0.0023. Okay, and then from there, you should get an answer. So negative log 0.0023. So we had 2 significant figures, so your answer should be 2.6. Yeah? Okay, so if our pOH is 2.6, is that acidic or basic?
Basic.
Good. Okay, it's basic. Then we have this other little fancy equation down here at the bottom. I called it a bonus equation. This is going to be a very, very, very handy equation for you. So star it, highlight it, circle it, put hearts around it. Okay, this equation is going to help us go in between substances that, or go between talking about hydrogen and hydroxide. Okay. This will allow you to go between talking about hydrogen and hydroxide. Okay, so like your pH equation only uses hydrogen. Your pOH equation is only talking about hydroxide. This friend, this magic equation, this pH, pOH friend, helps us go between the two. Okay, super easy. pH plus pOH equals 14. You will always be able to find out or know the pH or the pOH. And so you would just take 14 minus whatever. Okay, so it's nice and straightforward. Great equation. We're not going to use it much today, but I want you to be aware that it exists because it will come up in your video lecture on Monday. Okay. Next up, doing the opposite. Okay, so it can be super useful if you know hydrogen concentrations to calculate pH, but if you know pH, we could also use that to determine our hydrogen concentration in solutions. And so we're just using the opposite of log. It's called the inverse log. Again, if you're not a log person, no worries. I just need you to know the button on your calculator. Okay, so no fear there. All right. So if you look at your calculator, and if you look at the actual calculator above the word log, like on the back part, you should see 10 raised to the x. Does everybody see that on your calculator? Okay. So do not confuse inverse log with natural log. Okay, we do not want to touch that ln button. Okay, we want the button above it that says 10 raised to the x. So to get that on your calculator, you're going to press second log. Okay, so you can fill this in on your notes. You always want to press second log. And then negative whatever the pH value is. Oh, and that question below doesn't actually make sense. Because why would we want to, that's the wrong kind of practice problem. So let me give you a different practice problem. Scratch that. All right. Let's see. We'll cover that, get rid of that, go away. Okay, I want to know what, whoa, that got small. You guys can see this live typing on your screen, right? Okay, I want to know what is the hydrogen concentration if the pH is 1.44. When you get an answer, type it in the chat, please. Do we have questions? Because this should be a quick calculation. So if you need help, let me know. So one thing I will say is we want to have 3 significant figures because 1.44 was 3 significant figures. So we're going to keep 0.0. Remember that one in front is just a placeholder. Okay, so you should have 0.0363. The other thing to keep in mind is that these numbers are a concentration. And so when you are solving for a concentration, you need to include a unit. So 0.0363, big M. Okay, so I just typed it in over there in the chat. Okay, 0.0363, big M. Okay. Rid of that. All right. So you've got 2 to plug in just to make sure. So please do those 2. Excuse me. Make sure you're reading that whole, make sure you're reading the whole calculator. I'm seeing a lot of 2.81, 2.812, things like that. 2.82, 2.818s for that one. And then also being careful with sig figs. 4.00 is how many significant figures? 3. Okay, so it looks like most of us are not having trouble plugging it in, so that's good. Okay, so the first one you should have 1.00 times 10 to the negative 4th, big M. Okay, and then for the second one, 2.818 times 10 to the negative 12th, big M. Okay. And so we can do the same thing using pOH as we did using hydrogen. Okay, so it's the same equation. We're going to do the exact same thing, but sometimes we want to measure hydroxide concentration as opposed to hydrogen concentration. And so over here, noticing the equation 10 to the negative pOH, that's exactly the same thing. So on your calculator, just give yourself that reminder in your notes, right? Because you're not with me every day. You're not going to hear me saying it every day. You're going to use second log, okay, to get that button. Second log to get 10 to the whatever. And again, make sure you're using the negative key instead of the subtraction key. And that will definitely cause you some problems. And so for that first one, it says if the pOH is 5.22, what is the hydroxide concentration? So on my calculator, I would press second log negative 5.22. 5.22 has 3 significant figures, so I'm going to keep 3 for my answer. And so over here in the chat, you will see 6.03 times 10 to the negative 6, big M. And you've got 2 for you to do. And just like before, fire them off in the chat, please. Yeah, Michaela.
I think I missed it, but what equation do you use for this type of question? Is it the same one we just used, or?
Yeah, so right here, right? So it says using pOH to get hydroxide concentrations. You're using 10 to the negative pOH. Okay, so it's the same equation. It's just you're getting OH as opposed to H.
Thank you.
Uh-huh. Okay, so it looks like what's coming in is good. It might not be a bad idea to give yourself a reminder in your notes for this equation and the one prior that you need to include a unit. Okay, so give yourself that reminder in your notes because again, you won't hear me saying it to you every day. What's the unit? What's the unit? What's the unit? Okay, so again, for hydroxide concentration and hydrogen concentration, your unit is big M. For pH and pOH, there is no unit. Okay, the answer is just like 5.2. Crazy. Finally get something without a unit in here. Okay. So you're gonna have a little practice using these equations. You're gonna have an activity to do. And then hopefully you saw next Thursday is your final assessment for the class. Okay, so as a reminder, if you need any form of extra help, okay, that you need to be using the Google form to request it, okay? I just want to make sure I'm not missing emails, and I was missing some requests for extra help, and I felt really bad about that. And so the Google form keeps it all perfectly organized for me. Okay, so if you need extra help, please use a Google form to request it. And then next week, like I said, you'll have some practice and another video lecture from me. And then before the test, that Wednesday is technically not a Zoom day. And so because we're using the Zoom day to do your test, so I will be on during class. There will be a review sheet posted for you to do during that time. I will not be giving any new information during that time. I want that to be very clear. Okay, so that Wednesday before your test, there is no new information. It will be listed as a optional Zoom if you want to come and work on your review sheet, ask questions, practice problems with me right around, okay? But no new information. So if you can't be there, there's zero penalty and zero things missed, okay? Does everybody understand that? Yeah, Hayden, what's up?
6 weeks.
Will the test format be the same as last time?
And while
I
you're
haven't
doing
decided. I haven't figured that out, but it will be done in one day. So that's different. It's a lot shorter because of timing. So it won't need, it's essentially kind of like a halfway quiz in terms of content. There's a whole nother half to this unit that we're not doing. Any other questions about this material or the test or anything like that that I can do to be helpful? Yeah, Michaela.
Can you go over how you got the second answer, please?
Yeah, so you're just you're going to plug into your calculator. You're going to do second log, the negative key down at the bottom, and then 2.85, and you should get 0.00141.
Okay.
Yeah. And you'll get practice plugging these friends in too. All right, my friends. Well, I hope you have a wonderful day. If anything comes up, feel free to reach out. And again, use the Google form for extra help, please. Okay? Bye, friends.
Thank you.
Thank you.
You bet.
Thank you.
Thank you.
All right, let me stop the recording here real quick, okay?